In section 7.5, we are going to continue section 7.4, where we are going to simplify differentiation by modifying the form of the polynomial function. In page 125, we can read, you can expand or simplify polynomial functions so that they are easier to differentiate. Then, if we have a polynomial function, we can expand it or simplify it so it becomes easier for us to make differentiation and to find f prime of x. What does that mean? Let's try solving an exercise or example 9 so we can better understand. Use standard results to differentiate. We have part A, B, and C. Let's start with part A. We have 1 over 4 multiplied by the square root of x. This should be rearranged so it becomes in the form of A multiplied by x to the power n. We already know 1 over 4 is the coefficient and 1 over x is the same as 1 over x to the power half. We know the square root of x, it means x to the power half. Then moving this x to the power half to the numerator, it will be x to the power minus half. Then the answer is 1 over 4x minus half. Now this is easy to differentiate. dy by dx will be 1 over 4 multiplied by n, that is minus 1 over 2 multiplied by x to the power minus half minus 1. This is equal to minus 1 over 8 multiplied by x to the power minus 3 over 2. Now you can see after we modified the example that we have into the shape or into the form of y equal ax power n, it is easier to find that differentiation. Part B, we have y equal x cubed multiplied by 3x plus 1. We did not study how to do this multiplication or to derive this multiplication process. So let's expand this form and try to see how it will look. Then y equal x to the power 3 multiplied by 3x is equal to 3x to the power 4. X to the power 3 multiplied by 1 is x to the power 3. Now we have two terms that can be easily differentiated. dy by dx equal the first term 3 multiplied by n, that is 4, and from x to the power of x we reduce 1. Same thing for the other term, 3 multiplied by x and the power we reduce from it 1. So we get 12x cubed plus 3x squared. You can see we expanded the form that we have so it becomes easier for us to differentiate. In part C we have x minus 2 divided by x squared. This is division and we have no rule to use now to differentiate. So let's rearrange or modify this expression. We can say x over x squared minus 2 over x squared. The same denominator distributed with the numerators. Then now y equal x over x squared is equal 1 over x minus 2 over x squared. Let's modify these terms to be on the form of ax power n. Then we can say x to the power minus 1 minus 2x into the power minus 2. Now we can differentiate easily. dy by dx for the first term is minus 1 or n multiplied by x to the power minus 1 and we reduce 1. Then it becomes minus 2. Same thing for the second term, minus 2 multiplied by n, that is minus 2 multiplied by x into the power minus 2 minus 1, that is minus 3. This is equal to minus 1 multiplied by x to the power minus 2 minus 2 multiplied by minus 2 is plus 4 multiplied by x to the power minus 3. Now we can fix this expression so it becomes as fraction minus 1 over x squared plus 4 over x cubed. We can write it so, or we can make it on the form of part C, so it becomes x cubed, and then we can multiply the first term by x, both the numerator and the denominator, so it becomes minus x plus 3 divided by x cubed. X cubed is the common denominator. As you can see, it is easy to expand or to differentiate any expression if we modify the expression that we have so it fits with our standard differentiation rules.